in Calculus Chapter 3, Section 4, we're going to look at exponential functions. And just to keep this very straightforward, the derivative of e to the x is actually just equal to e to the x. Now notice that you're still going to need to do the chain rule along this. That's all you need to know as far as the scope of Calc AB, Calc 1. But in a future math class, they might ask a little bit more out of this. So what do I mean by the chain rule? Well, if you're asked to find the derivative of this function, it stays as e to the sine of x. But then you need to multiply by the derivative of sine of x, which is cosine of x. Now, if you want to rewrite this, like multiplication is commutative, you could, but you don't have to. Maybe I'll do the next one slightly different. So the derivative of this function is the derivative of e to that function is e to that function. But then you have to multiply by the derivative of 2x plus 3. Well, the derivative of 2x is 2, and the derivative of 3 is 0, so you don't need to write that. That's it. Just keep going. I'll just change colors sort of to make this a little bit more vibrant. But yeah, let me actually rewrite this after I do this. So the derivative of e to the 2x is e to the 2x, but then you have to multiply by the derivative of 2x, which is 2. So I would rewrite this problem because 3 times 2 with multiplication being commutative, associative, whatever those words are, you can write as 6e to the 2x. Now, let's make this a little bit more difficult. So what do you notice in this next one is the product rule. We have a product with an independent variable to the left, and an independent variable to the right. Now, notice that we also have the chain rule to the right. So stick with me. This derivative, it may seem daunting, but it's not that bad. Well, the derivative of the left is just 2. Leave e to the 3x alone. Not sure why that just happened. E to the 3x. And then plus, leave 2x plus 3 alone. And then the derivative of e to the 3x is e to the 3x times 3. Now, if you want, you can leave it like that. I've seen teachers also ask their students to factor out an e to the 3x. So they'd factor out e to the 3x. You don't have to do this, by the way. That's just something I've seen teachers do. And then, let me just go back. You can distribute this 3 in here. So we're looking at 6x. And I would write plus 9, but then we also have this plus 2 right here. So you might actually see it written as plus 11. And hopefully that makes sense. By the way, feel free to pause the video at any point and really understand this. I figured I would share the answer key here just to have you guys realize that you can have multiple ways of writing these answers. And if you're looking over here, you can see a little bit better way of a step-by-step process. But I like doing math in my head. I think you guys know that by now. To get this final answer. So again, pause the video, and I'm going to go back to the notes. So looking at the next one, definitely have a product rule in here. And as you're looking at that product, we also have a chain in there, e to the 2x of the chain. So if I were doing this problem, I would just do the product rule of 2x, derivative of x squared, leave e to the 2x alone, plus leave x squared alone. The derivative of e to the 2x is e to the 2x times 2. Well, I want to squeeze that in there. That's what I'm going to do, squeeze the 2 in front. I would probably actually just leave my answer like this. But again, if I were to go to the answer key, I'd be willing to bet that that individual factor out a 2x e to the 2x. And then, let's see, that's all of that. And so they'd be left with 1 plus x. So again, multiple choice questions could be factored, could be simplified, could have multiple things going on. But that's about it. Now this last one, it may seem like magic. But I just want to remind you, if there's shortcuts, go ahead and take them. For instance, this is e to the 2x minus 6 to the 1/2 power. Well, if you have a power to a power, this is simply e, as you distribute that, to the x minus 3 power. So what should the derivative of this be? Well, the derivative of e to the independent variable is itself times the derivative of x minus 3. Well, x minus 3 is just 1. Now, if you don't believe me, could you have worked it out looking at this original problem? I'll do this in red. Sure, you could have. It's a chain rule inside of a chain rule inside of a chain rule. So if you brought that 1/2 in front, e to the 2x minus 6 is now to the negative 1/2 power times e to the, you have to take the derivative of e to the 2x minus 6, which is just e to the 2x minus 6, times e to the, nope, not e, times the derivative of 2x minus 6, which is just 2. Well, as you do some simplifying, you'll notice the 1/2 times 2 cancels. And this is the same thing as to the first power. I'm not sure why that's happening to me right now. Well, if your bases are the same with multiplication, you can add your exponents. So that's the same thing as e to the 2x minus 6. Well, negative 1/2 plus 1 is 1/2. And we're back to that same dilemma that this is equal to that, which I already mentioned before. So if you feel like you're doing something wrong, you probably are not. Well, I guess you might still be doing something wrong, but there might be a faster way as well. So here's another problem where they just want to stick a quotient rule inside of that. So make sure you're familiar. So this is definitely a quotient rule. So the derivative of the top, and as you get a lot of practice, you'll know fairly quickly how to do this. Leave the bottom alone, minus the derivative of the bottom, which is 6x. Leave the top alone. All over the denominator squared. Make sure you square each piece. So 3 squared is 9, x to the 4th. Now, let's go ahead and simplify this. Some teachers would let you stop right there. But as I'm looking at this, I see a 3 goes into each term, and x goes into each term, and the e to the 5x is in each term. So then, let's see, I already mentioned, let me use a lighter color, that I took care of this, and one of these. So that tells me that I'm left with 5x minus, let's see, I took out a 3 from that 6, so it's 2. I took out an x, and I took out the e to the 5x. And maybe rewrite this as 3x times 3x to the 3rd. So then you could simplify the 3's there, and we're just left with this nicely simplified problem if you take it all the way down. There you go. Fairly nice answer. All right. Now, if that was not enough, we also have a differentiation rule for natural log functions. So, the derivative of a natural log function is equal to 1 over x. Now, again, I need to point out that you'll have the chain rule in here. So in a math textbook, you might actually see this written a little bit differently. But I don't want to confuse you with fancy notation, and I feel like math books get fancy. And this is easy for me to remember. And the reason why it's easy for me to remember is this is the only function that it can't have a derivative with a polynomial. And you might be saying, well, what do you mean? And I would answer that with, think about for a second. If I had the derivative of x to the n power, you bring the n in front, and then it becomes x to the n minus 1 power. So this derivative is the same thing as saying, x to the negative first power. Well, if you were to look at this problem then, I'm looking up here again, is if the final answer is -1, then that means n equals 0. Well, what does it mean if n is 0 in the original problem? Well, x to the 0 power is equal to 1 no matter what. And we already know that the derivative of 1 is equal to 0. So the only way to get the answer of a derivative to equal 1 over x is if we're talking about natural log of x. So if I ever forget what the derivative of natural log is, I go back to this thought process of what's the only derivative that I can't use with a polynomial, and that's x to the -1 power. If that didn't make sense to you, that is perfectly fine. You can memorize it. And again, just make sure you remember the chain rule. So as I get to this problem of the derivative of this function, all you have to do is think about, okay, well, it's natural log of this function, so it's going to be 1 over 2x minus 3, but then you have to multiply by the derivative of 2x minus 3, which is 2. And as you multiply by a whole number, it just gets stuck into the denominator. So if you read another math book or you go talk to another math teacher, they might say it's the derivative of natural log is the derivative of the inside on top over the original function. And that's exactly what happens here. So if you follow that rule, I still don't want to teach it that way, so I'm not going to. So remember, the derivative of natural log is 1 over that function, 3x squared plus 2x. But then you need to multiply by the derivative of that function, which is 6x plus 2. But again, if you follow the advice of another teacher, they might just say, well, take the derivative of the inside, which is 6x plus 2, over the inside, 3x squared plus 2x. So this is your final answer for that problem. Okay, so how can we make it more complicated? Of course we can make this more complicated. Is the derivative of natural log of cosine? Well, let's follow our advice, or at least my advice, that it's 1 over cosine, but then you need to multiply by the derivative of cosine, which is negative sine. So as we're looking at that, okay, well, we can multiply that into the numerator. Well, you should have learned in pre-calculus that this is a special function. Sine over cosine, I don't know why I just wrote a t there, I actually do know why, is I was thinking ahead that that answer is tangent of x, and the negative is still there. Okay, so the next one. There's a fast way to do these natural log problems, and this is why we force you to learn natural logs in pre-calculus. Is don't forget, I'm just doing the function again, I'm re-examining this, that this is 2x minus 4 to the 1/2 power. Please don't forget, a rule for a law of logs is you can move that power in front, and it is exactly the same value. So now when you're asked to do this problem for the derivative, you just look at that and say, oh, well, 1/2 times 1 over 2x minus 4 times the derivative of 2x minus 4, which is just times 2. Well, that's kind of nice. This 1/2 times 2 would cancel, and this would be your final answer. Now, if you didn't think about that, that is perfectly fine, because if you did this, let's go back to red, because I did this the other day in red. Gotta try and finish this in a minute. And you did, okay, well, the derivative is 1 over that function. Well, then you'd have to multiply by the derivative of that, which is 1/2. That 2x minus 4 is now to the negative 1/2 power times the derivative of the inside is 2. And then you could look at that and say, oh, well, that's the same thing as 1 over the square root of 2x minus 4 times 1 over the square root of 2x minus 4. Well, wait a minute. The square roots, when you multiply them together, will cancel. Will give me that answer. So I'm going to let you pause, watch, make sure you understand, and I have to make another video to finish these notes.